So Hemogenyx is trying to change the way bone marrow transplants are being done. Bone marrow transplant is a procedure that is given to people who suffer from severe blood diseases such as leukemia, lymphoma, multiple myeloma, bone marrow failure, and so on. Most of these people who are diagnosed with these diseases, they go through a frontline therapy. And unfortunately, many of them fail that frontline therapy and the disease comes back. For these people, there is only one hope, and that hope is a good bone marrow transplant. A typical bone marrow transplant is subdivided into two phases. Phase number one is conditioning or preparation of the patient for the bone marrow transplant. And phase number two is actual transplantation of blood stem cells. Both of these phases have severe limitations. Phase number one is usually done today by chemotherapy and radiation. And both chemotherapy and radiation have severe side effects. They're toxic. And phase number two has also severe limitations. And these limitations is the lack of donors and rejection of the transplant. We're trying to eliminate problems associated with the phase one of bone marrow transplant, which is conditioning of the patients, by designing and developing a unique type of antibodies, we call them CDX antibodies, that redirect immune cells of the patients to attack and eliminate blood stem cells of the same patient. This type of antibody will hopefully eliminate chemotherapy and radiation and solve the problem of non-specific toxicity of these treatments. The second phase, we're trying to solve the second phase, the problems associated with the second phase of any bone marrow transplant by using the cells that I discovered when I was at Cornell. And these cells can be extracted and purified from the patients themselves and used to generate new blood stem cells that can be used for the transplantation back into the patients. This approach will eliminate the need for donors because these cells come from the patients themselves, and will probably improve the outcome of the transplant simply because they are 100% matched to the patient and they did not accumulate mutations and chromosome rearrangements that are usually accumulated by standard blood stem cells of the patient. There are about 20,000 bone marrow transplants being done in the US every year. There are about twice as many done in the European Union. This translates roughly into $8 to $9 billion a year market size. That's the market we are addressing. But there is much more than just money. We're trying to significantly improve bone marrow transplants, the procedure itself. And this will allow to deliver it to many more people who cannot get this procedure today. And this will ultimately translate into saving a lot of lives. We're developing two novel product candidates that we think are much better than anything in existence today. We also have a very good idea how to put these products on the market. We believe that when these products are on the market, they will be complementary to each other, but in the same time can be used separately. When these products are on the market, they will completely change the way bone marrow transplants are being done today.